Welcome to part 7 of our series in quadratics. Now in this video we're moving on to something called completing the square, and this really is just an introduction to a topic that's quite far-reaching and there's quite a bit more to do, but I'm going to just give you the very basics of what it means in this introduction. Alright, now for the moment I have plotted the graphs to show the functions y equals x squared plus 4x minus 5 and y equals x squared plus 4x minus 2. Okay, and they're in red and blue as shown on the graph there. All right, now I just want to point out that I'm not dealing with solving quadratic equations. I'm just looking at changing the expression, a quadratic expression, into what we call a completed square form, and the information that gives us about the graphs. Okay, we will move on to solving equations through completing the square in later videos. Okay, so this is what you need to understand first of all before we start to look at completing the square. Okay, if you take a perfect square and multiply it out, what happens? Let's do some examples of that first. So these are what we call perfect squares. So for example, we've got well, let's say x plus 1 squared. Okay, it gives us x plus 1 times x plus 1. Okay, and that in turn will give us x squared plus 2x plus 1. Okay, right, now we need to do a couple more before you can see what this is about. I'm now going to do x plus 2 squared. Okay, for the moment I'm just going to keep the x coefficient as 1, and I'm going to have x plus 2 times x plus 2, okay, and it's going to give me x squared plus 4x, because it's going to be plus 2x and plus 2x plus 4 at the end. Okay, and if I were to do x plus 3 all squared, I will miss out the next step, because I think you might be able to see that that's going to lead on to x squared plus 6x plus 9. All right, and there are patterns forming there which I hope you can see. All right, now the most significant and important part of this is to recognize that whatever number you've got here at the end of the bracket, you double it to get the coefficient of x in the expansion. So double 1 gives me 2. Okay, double the 2 there gives me 4. Double the 3 gives me 6, and so on. And that will always be the case. Okay, so whatever number is at the end of that bracket, when you square it, will result in the x term having a coefficient of twice that number. Okay, now completing the square makes use of that fact. Okay, because what we try to do when we complete the square is make a perfect square from something like this or this, and then see what's left over. All right, now if I were to play this backwards, this one here for example, I know that that is equal to x plus 3 all squared with nothing left over. But if I were to have here, say instead, I'd had x squared, let me go into a colour that you can see. So let's suppose this had been x squared plus 6x plus 10 instead of 9, and I wanted to go back into a perfect square. Okay, so I'm going that way. I couldn't put that into a perfect square, but what I could do is I could say it must be the same as x plus 3 all squared, right, which I know gives me x squared plus 6x plus 9 plus another 1, all right? And that is the process of completing the square. Going from that to that, and then sorting out the leftovers, if you like, to see what you need to add or subtract at the end. Okay, so had this been, just for one more example, had this been x squared plus 6x plus 8, and I wanted to complete the square, then I would know to go back to x plus 3 all squared, but this time I would have to subtract 1 to keep it correct. Okay, so that's a sort of an introduction to what the connection is between completing the square and the perfect square. So how does it apply to these examples here? Well, I'll show you. Let's start by taking out, I'll just take some of this stuff out the way, or at least move it up out the way. Okay, so I've got a bit more space. I'll just put that up there. Okay, now if we take this first example here in red, okay, so I shall write in red referring to this one here, then I'll switch to blue when I come to this one. Okay, so looking at this equation here, I'm going to do similar to what I did here. I'm going to look at the x term and halve it, okay, because that went from 6 down to 3. So this is going to go from 4 down to 2. And I'm going to consider what I would get if I did x plus 2 all squared, okay. So I'm going to consider what that gives me. Well, it gives me x squared, right, plus 4x, and it would give me a plus 4 at the end, okay? But I have a minus 5, okay, not a plus 4. So if I was going to complete the square for this, okay, what have I got to do to the plus 4 to actually turn it into a minus 5? Well, I would have to subtract 9, wouldn't I? So I could say that the first one in completed square form is x plus 2 all squared, okay, which we know would give me this, but now I've got to take away the 9 from it, so I must take away the 9 from it here as well, okay. So in other words, if I took that whole thing there and worked it out, it would be equivalent to this here, okay. Let's just quickly check it. X plus 2 all squared is x plus 2 times x plus 2, which is x squared plus 4x plus 4, and then the take away 9 is that, and we know that if we add 4 and take away 9, it will give us negative 5, okay. So that is in completed square form equivalent to that, okay. That's the completed square form of that. Okay, so let's take this one now, and I'll do this in blue to correspond to the color of the graph as well, and I want to show you some really important stuff about the graph in a moment. So I'm going to consider, well, we know already that x plus 2 squared will give me x squared plus 4x plus 4, all right. So I'm just going to say now that what we have here is x squared plus 4x plus 4, but to get it to be minus 2, I need to subtract 6, okay. So therefore, in completed square form, this is x plus 2 all squared minus 6. And that makes sense because you can see that there's a difference of 3 between these two, and there's a difference of 3 between these two. Okay, so the completed square version of this is this. Now, it's quite easy to go on to solving quadratic equations using completing the square, and we will do that in another video. But what I want to show you at this point is the geometric significance of this when we look at the graph. Okay, so if we take the first one here, x squared plus 4x minus 5, the graph in red here, okay, look at the minimum point on the graph here. Okay, the minimum point has coordinates -2, comma, -9. All right, -2, -9. That's the minimum point on the graph where it turns and starts to go up again. All right. Now, compare that with the completed square form and just notice two things, that number there and that number there. Okay. Right, now we look at the minimum point on the blue graph, and we see that it's there, and it has coordinates -2, -6. All right, -2, comma, -6. And we look at the completed square form of the blue curve, and we notice a 2 and a 6 there. But very specifically, what is the same and what is different? Well, the minimum point is for certain the residue, the bit that's left over in the completed square. So if that's -9, then the curve has a minimum point with a y coordinate of -9. If that's -6, the curve has a minimum point of -6 on the y coordinate, right? What you've got to be aware of is in the bracket, okay, the x coordinate of the minimum point is the negative of what's in the bracket. So if it's +2, that's why the x coordinate of that minimum point is -2. So the minimum point of a quadratic curve is the negative of that, comma, that. All right. Now, one more thing before this video ends. Why is that the negative point? Well, if you think about the expression x plus 2, for example, all squared, then the minimum value that can take is 0. The minimum anything can take if you square it is 0, because when you square a negative number, it's positive. When you square a positive number, it's positive. So the smallest thing that you can square to get the smallest answer, if you like, is 0. All right. So in other words, what we're really saying here is that what causes this bracket here to be 0? Well, it's -2. And what causes this bracket to be 0? It's -2. All right. So that's how this negative comes about here. All right. So in general, if you've got the quadratic that begins x squared plus bx plus c, okay, to begin the completed square process, you need to consider x plus a half of b, okay, all squared. You need to consider that, and then there might be some, well, there will be some adjustment to make as well. So that's the introduction, and we'll take this further in the next videos.